Although they are experts in the water, most crocodilians are also surprisingly competent on land. Nonetheless, even the fastest of today's crocodilians would have been put to shame by the prehistoric Boverisuchus. This fully terrestrial crocodilian lived during the Middle Eocene, about 48 to 41 million years ago. After the extinction of the non-avian dinosaurs at the end of the Cretaceous period, this land croc became one of the top predators of the newly ascendant mammals. It is nicknamed the Hoofed crocodile for the large blunt claws it evolved to help it traverse on land. Yet despite its evolutionary convergence with many of today's mammals, Boverisuchus may have also been capable of limited bipedalism, echoing its distant dinosaurian cousins. Older media, including the TV series Primeval, refers to Boverisuchus as Pristachampsus. Boverisuchus was first named in 1938, but was later synonymized with the previously named Pristachampsus. In 2012, the type specimen of the Pristachampsus genus was found to be undiagnostic, so Boverisuchus was again considered valid. There were at least 2 species of Boverisuchus. The type species, Boverisuchus magnifrons, is basically the same animal as the now invalid Pristachampsus type species, Pristachampsus rollinatii. All definitive Boverisuchus magnifrons fossils are from Germany, although fossils which may belong to it have been found as far as Central Asia. The second species, Boverisuchus vorax, lived in North America, with all definitive fossils coming from Wyoming. Additional Boverisuchus fossils have been found in Texas, Italy, and Romania, all of which may represent new species. The Romanian fossils are notable for being from the late Paleocene, making them roughly 10 million years older than the other Boverisuchus fossils. The hoofed crocodile grew 3 meters long. Although it may not have been as large as many of the predatory theropods it replaced, Boverisuchus was still large enough to compete with the Middle Eocene's largest mammalian predators, such as the hoofed Harpagolestes and the local species of the creodont Hyaenodon. As a fully terrestrial animal, Boverisuchus's limbs were straighter and longer, and its leg muscles more robust than those of other crocodilians. Besides sheer mass, the position of these muscles made Boverisuchus better suited for running at high speeds. To put this into context, many of today's semi-aquatic crocodilians are actually capable of galloping, the fastest reaching speeds of over 20 miles per hour. Boverisuchus would have left them in the dust. Many of its terrestrial adaptations echo those of the distant ancestors of crocodilians, who lived during the Triassic period nearly 200 million years before it. Of course, when it returned to land, Boverisuchus evolved traits not present in its Triassic predecessors, namely its famous hooves. These consisted of 3 large, blunt claws on each foot, which were the only toes which made contact with the ground. By spreading its weight across these larger claws, Boverisuchus's feet would have been more resistant to stress, allowing it to safely gallop at higher speeds. However, galloping may not have been the hoofed crocodilian's only option. Between the length of its hind legs and the orientation of their muscles, it is possible Boverisuchus could have run on 2 legs. This inspired the bipedal hoofed crocodile in Primeval. Of course, merely being possible within the confines of the existing data is not the same thing as knowing for sure that Boverisuchus was an actual biped. Still, as strange as a bipedal crocodilian may sound, their Triassic ancestors were facultative bipeds, and some of their relatives, like Postosuchus, were obligate bipeds. Likewise, footprints from early Cretaceous Korea suggest Boverisuchus wasn't the first of these reptiles to regain the ability to run on just 2 legs. Named Batrachopus grandis, the footprints seem to have been made by a bipedal crocodilomorph at least as large as Boverisuchus. Still, although the hoofed crocodile was portrayed with an almost human-like stance in Primeval, Boverisuchus was incapable of this. At most, it could only have assumed a 2-legged stance while running. The rest of the time it was restricted to walking on all 4s like any other crocodilian. Whether it ran on 2 legs or 4, perhaps Boverisuchus's greatest challenge when chasing its food was its own metabolism. Ectotherms have limited stamina, and crocodilians can only gallop short distances, with most tiring out after galloping a mere 20 meters. As it switched to a terrestrial lifestyle, Boverisuchus may have evolved a higher metabolism. Just like a crocodilian walking on 2 legs, the idea of a warm-blooded crocodile is not as far-fetched as it may sound. the larger clade crocodilians belonged to, Pseudosuchia, ancestrally had an intermediate or mesothermic metabolism. Those with the highest metabolisms were ironically the direct ancestors of today's cold-blooded crocodilians. Additionally, other terrestrial ectothermic predators, like monitor lizards, have evolved a higher metabolic rate even if they remain within the ectothermic range. Unfortunately, no analyses of the bone histology of hoofed crocodile fossils have been conducted to confirm if this was true for them as well. Even if Boverisuchus's metabolism was not the equal of its Triassic ancestors, the wider world it lived in would have helped to compensate for this. Ectotherms thrive in warm climates, and global temperatures were much higher during the Eocene than today, to the extent that even parts of Antarctica were subtropical. Additionally, tropical forests covered most landmasses. Such habitats would have provided Boverisuchus with plenty of places to set up an ambush before making short, swift dashes after its prey. Once it caught them, Boverisuchus did not dispatch its victims in the same manner as other crocodilians. The teeth of both species of hoofed crocodile are zyphodont, meaning they were compressed, recurved, and serrated. Their semi-aquatic relatives have straighter, conical teeth, which are used to firmly hold on to their prey as they drag them into the water. The zyphodont teeth of Boverisuchus instead evolved to slice through flesh, killing their victims through blood loss. Zyphodont teeth independently evolved in a number of other land crocs, as well as in theropod dinosaurs and monitor lizards. Boverisuchus's skull is much deeper, and thus would have been less hydrodynamic than those of modern crocodilians. It is also the source of one of the distinctions between the two species, as the snout of Boverisuchus vorax is notably broader than that of its European cousin. Like other crocodilians, Boverisuchus's body was covered by osteoderms, bony plates within its skin. Crocodilians use osteoderms for a variety of purposes, including armor, thermoregulation, and mechanical support when running. The latter purpose is likely partially responsible for why the hoofed crocodile had even more extensive osteoderms than its surviving cousins. Boverisuchus may have also needed the extra protection since it could no longer flee to the water when it felt threatened. Boverisuchus's tail was very different from those of other crocodilians. Theirs are flattened on the sides, a shape which allows them to serve as effective sources of propulsion in the water. Without this tail, they would be more awkward in the water than they are on land. The tail of Boverisuchus was instead round, like most other land crocs. Furthermore, it was entirely encased in osteoderms, meaning it couldn't make the side-to-side movements that propel crocodilians through the water. It is therefore apparent that the hoofed crocodiles had put their days as amphibious predators long behind them. Boverisuchus did not belong to any of the three major clades of modern crocodilians, but to the now extinct clade Planocraniidae, previously called Pristochampsidae. All other known planocraniids are only known from skulls. Like Boverisuchus, they had deep snouts, but their teeth don't seem to have been as well adapted for life on land. The most basal known planocraniid is the small Duerosuchus, who lived in Spain during the Middle Eocene. Its teeth are more circular than those of Boverisuchus, lack serrations, and only its front teeth are recurved. More closely related to Boverisuchus is Planocraniidae's namesake, Planocrania. It consisted of two species, both of which lived in late Paleocene China. Planocrania teeth are compressed and have fine serrations, whereas the serrations of most Boverisuchus teeth are more robust. The exception is the Boverisuchus fossils from Paleocene Romania, whose teeth have fine serrations like those of Planocrania. It is unclear where Planocraniidae fits within Crocodilia. It is sometimes found to be closely related to crocodiles and gharials, although since it belongs to neither group, the hoofed crocodile is technically not a crocodile at all. Some studies have even found that Planocraniids may not be true crocodilians. Crocodilia consists of all its living species and the descendants of their last common ancestor, and Planocraniidae may have evolved just before that common ancestor. If true, this wouldn't change much about our understanding of Boverisuchus, since crocodilomorphs much more distantly related to true crocodilians were already very similar to them in both appearance and lifestyle. What all studies agree on is that even though the oldest identifiable planocraniid fossils are from the Cenozoic, the clade first evolved during the late Cretaceous. Mesozoic Planocraniids are generally held to have been ecologically similar to other crocodilians, with their descendants only becoming terrestrial predators after the demise of the large carnivorous dinosaurs. Boverisuchus coexisted with other more traditional crocodilians. While the European Boverisuchus magnifrons terrorized mammals on land, Diplocynodon gave them reason to continue fearing the water. In North America, Boverisuchus vorax lived alongside the small, mollusk-eating Alagnathosuchus and the larger Borealosuchus, a survivor of the end Cretaceous mass extinction. A more distantly related group of crocodilomorphs, the terrestrial Notosuchians, also survived into the Cenozoic era. One of these land crocs, Boverisuchus, was a contemporary of Boverisuchus magnifrons. At 1.5 meters long, it would have been lower in the food chain than the hoofed crocodile. Even though the non-avian dinosaurs had been extinct for 20 million years, most mammals of the Middle Eocene remained small, perhaps in part due to the prevalence of dense, tropical forests. Both species of hoofed crocodiles hunted the early horses of their time, and it has become something of a paleoart meme to depict Boverisuchus chasing them. The largest item on the menu for Boverisuchus magnifrons would not have been a mammal, but the giant flightless bird Gastornis, which, despite its portrayal in Walking with Prehistoric Beasts, was a herbivore. In North America, Boverisuchus vorax lived alongside the iconic mammal Uintatherium, who was likely too large for it to bring down. The leading hypothesis for the extinction of the hoofed crocodiles is that they were outcompeted by mammalian predators. This hypothesis was formulated during a time when the same was thought to be true of the non-avian dinosaurs, and reflects the mammal-centrism of the time. Competition for mammals is an unlikely explanation for the disappearance of Boverisuchus, since it coexisted with large mammalian carnivores for some time, and large ectothermic predators existed long after it. Examples include the famous monitor lizard Megalania, and the Notosuchian Boverisuchus, who was perhaps the largest land predator of the entire Cenozoic era. In Boverisuchus's case, it is not even certain whether it even was an ectotherm, or mesothermic, or outright endothermic like most mammals. Instead, like so many other amazing creatures, the hoofed crocodile may have been a victim of climate change. Global temperatures declined during the late Eocene, bringing with them the end of the global tropical forests. Lower temperatures would have been a major problem for Boverisuchus if it was an ectotherm, but climate change brought about other, more indirect perils. As the dense forest receded, the hoofed crocodiles would have found fewer places to hide, while their prey would have had an easier time evading them in the more open environments which replaced them. Additionally, as the climate changed, not all of Boverisuchus's prey survived the transition, and the hoofed crocodile may have simply perished alongside them. Boverisuchus was perhaps one of the most fascinating crocodilians. It was not the only one to return to a fully terrestrial existence, but it developed a number of unique adaptations, ranging from hooves to possibly even limited bipedalism. It is also yet another example of just how adaptable crocodilians can be when given the opportunity.
Thank you for watching, and a thank you to themattalorian for narrating this video. If you enjoyed it, please remember to hit the like button, and subscribe if you'd like to see more. Finally, be sure to have a great day.